Hello to all my English-speaking viewers. You are watching the Automation for Dummies channel. This is my first time making a video in English, so don't judge too harshly. If something is not clear, then in my defense I will say that I did not study English at school at all. And this video was translated using Google and Yandex translators. First, I would like to say a few words about my channel. The content on the channel Automation for Dummies is aimed at studying disciplines related to the automation of technological processes and production. These are such disciplines as theory of automatic control and regulation, programming of logic controllers, electrical engineering, and more. A new video has just been released on my channel, which is called The Simplest Valve Control Scheme, Part 1, and it was on this video that I decided to practice creating content in English. As you probably already guessed from the title, in this video we will talk about how the valve control circuit works. On the screen you see the simplest electrical circuit for controlling the valve. This scheme conditionally consists of two parts. On the left is the power section, which includes the electric motor and the power contacts of the magnetic starter. And on the right is the control circuit itself. I think it will be convenient if I immediately explain the principle of operation, talking about the purpose and internal structure of the individual elements of the valve control circuit along the way. The control circuit is powered from the power section. As we can see, a branch is made from L1 to the control circuit. We will assume that the valve is in the closed position. To open the valve, the operator presses the open button. In the diagram, this button is designated SB2. When pressed, the button contacts close, and L1, through the closed contacts of the stop button, indicated in the SB1 diagram, is fed to the inductor of the magnetic starter responsible for opening the valve. This coil is marked KM1 in the diagram. On the other hand, N neutral comes to the KM1 coil. Also in the circuit we see the closed contact of the limit switch SQ1, and the normally closed contact of the magnetic starter KM2, which is responsible for closing the valve. What they are for, I will tell a little later. Let's take a closer look at what a magnetic starter is, and what is the principle of its operation. I want to draw attention to one point. Very often a magnetic starter is called a contactor. In fact, this is not true. So what is the difference between a contactor and a magnetic starter? This question often perplexes the most experienced electricians, while many believe that the difference between them lies in their design, overall dimensions, or the value of the switched, rated, current, but this is not the case. According to IEC 60947, 4.1, 2021, a contactor is a contact switching device having only one rest position, non-manually actuated, capable of making, carrying and breaking electrical currents under normal electrical circuit conditions, including operating overload conditions. The same document gives us the definition of a motor starter. A motor starter is a combination of all the switching devices required to start and stop a motor, with overload protection. As we can see in the picture, the starter includes a contactor to turn the electric motor on and off, a thermal relay to protect the electric motor from overloads, buttons to control the contactor. All of these devices are often placed in a common housing. Structurally, the contactor consists of the following elements: moving and fixed parts of the magnetic circuit, an electromagnetic coil wound on a core, movable and fixed contact plates, a dielectric holder to accommodate the contact group. And the principle of operation of a magnetic starter is as follows. When the starter is turned on, an electric current begins to flow inside the inductor. Under its influence, an electromagnetic field is generated. The core is magnetized, and the field force compresses the spring, and begins to attract the movable part of the magnetic circuit. As a result of such an impact, the contacts close, and through them the power is connected and supplied to the load, after which the load starts to work. When the magnetic starter is turned off, the coil is de-energized. Under the action of a return spring, the moving element of the magnetic circuit returns to its original position. The main contacts open, and everything returns to its original state. So what happens in our circuit? When you press the button SB2, open, voltage comes to the inductor of the KM1 contactor, and its contacts are closed, including power contacts, through which a three-phase voltage is supplied to the electric motor, and it, in turn, begins to work to open the valve. The motor is running, and the valve is opening. But suddenly the engine stopped working, and the valve stopped. What happened? Why did this happen? But because the operator released the open button. Since the open button is non-latching, the electrical circuit is open, and the voltage in the control circuit is gone. To prevent this from happening, there is a self-locking contact in the circuit. The self-locking contact is one of the normally open contacts of the contactor contact group, which is connected in parallel with the open button. That is, when voltage came to the coil, all contacts closed, including the self-locking contact. And now the coil power has gone through this contact, bypassing the button. So the operator can safely release the button. Now the valve will open until someone presses the stop button, or until the mechanism of the limit switch box opens contact SQ1, which is responsible for reaching the open position of the valve. When the valve has reached the open position, the contact SQ1 opens, the voltage in the opening circuit disappears, the engine stops. In order to start the valve to close, the operator presses the button SB3 close. Then the process is similar to opening. That's all I wanted to tell you about this scheme. I hope my English was clear. In the next video, to see clearly how this circuit works, I will create a valve simulator in the Unity Pro development environment for programming controllers. Well, on this optimistic note, let me take my leave. Thank you for your attention. Subscribe to our channel. Goodbye.